So today we're doing the law of cosine. Remember our last two sections that we did were both with law of sines. So remember that when we're dealing with law of sines or law of cosines, we're dealing with things that have oblique triangles, which is why we can't use our Pythagorean theorem or just like our normal trig functions, because those have to deal with right triangles. Now remember, when we're solving for triangles, we said that there are four cases. The first two deal with law of sines, and we said that the second two deal with law of cosine. Okay? You will need to know which case deals with which law for your test. Okay, so make sure we know which one we need to use when. Okay. So today we're going to look at our second two, which deal with our law of cosine. So here's our law of cosines. The standard form is really what you need to know, because notice in our alternative form, all they did was solve for cosine, and most of us should be capable of solving for cosine in that. So all you have to do is subtract b squared and c squared, and then divide by the negative 2bc. Okay? You will have to have this memorized. Do you need to have all three memorized? No, not really, because notice if I have my first one memorized, it's going to work very similarly for the other ones. It's one of your sides squared equals your other side squared plus the other side squared minus 2, the two sides multiplied together, times cosine of the angle that's opposite of your isolated side. Yes? Okay. Now, what does that look slightly familiar or similar to? Yeah, it looks kind of like our Pythagorean theorem. So let's think about this. If I wanted to find the hypotenuse from my Pythagorean theorem using my law of cosine, right? So I'm looking at a squared. If that's my hypotenuse, then what would my big A have to be for a right triangle? If little a is my hypotenuse, it would have to be 90 degrees. So we would have cosine of 90 degrees. What is cosine of 90 degrees? 0. So what happens when I multiply anything by 0? It reduces to 0, yes. Okay, and so then we end up with just a squared equals b squared plus c squared, which is our Pythagorean theorem. Agreed? Yeah, so our Pythagorean theorem is basically just a really specific case of our law of cosine. We've actually been using law of cosine all along. You should know that's what we're actually using. We will suggest now you are going to need a calculator out. There will be some calculations that we need to do. So let's look at an example. So on this first example, they give us side, side, side. Now, we're in the law of cosines section, so obviously we're probably going to use law of cosines, but let's think, could I use law of sines if I wanted to? So remember that my law of sines is A divided by sine of big A equals B divided by sine of big B, or we could have C divided by sine of big C. So we have enough information to plug in A and B for our side, but do we have any angles to plug in? No. So do we have enough information that would allow us to be able to solve? No, which is why for this case, we can't use law of sines, because we don't have enough information to solve for anything. So what are we going to have to use instead? Law of cosine. Now, it doesn't really matter which side we start with. I usually just start with A because it's the first one. But they're all going to work really, really similarly. So, our law of cosine states that I have A squared equals B squared plus C squared minus 2BC times the cosine of big A. And then I'm just going to plug in the information that they give us. So we have 8 squared equals 19 squared plus 14 squared minus 2 times 19 times 14. And then we're solving for big A. So 8 squared gives us 64. And then what is 19 squared plus 14 squared? 557. And then what is 2 times 19 times 14?
132.
100?
500.
532. That sounds good. Now, can I subtract my 532 from my 557?
No.
Why not? Correct. So I have a multiplying by cosine for my 532. Order of operation tells us that we have to do multiplication before we can do subtraction. So we can't simplify that right now because we don't know what big A is. So instead, we're going to solve for big A. So what would our first step be? Subtract 557, and what do we end up with? And then we would divide. Is that correct? Yes? 32. So then, how do I get my A by itself then? We can't divide by a cosine. Remember, a cosine is an operator, just like a square root or any other type of operation. We can take the inverse cosine of both sides. The cosine inverse of 493 divided by 532. And we can plug all of that into our calculator. Make sure that we are in degree mode. And what do we get? 157? Round to 2 decimal places. 92 degrees. We get the same thing, different thing?
I got the
I got 22 Right.
Yeah, that's what I got too. Let's double check our answer. Yes, we should have gotten 22.08 degrees. So double check where your parentheses are when you're plugging in. And you might also make sure that we're in degree mode. Okay? Now, from there, okay, we can find big B next. So, do we technically have enough information now that we could use law of sines to find our big B?
Yes.
Yes. What would the only problem with that be?
Use round for our A angle.
Correct. We had to round to get our big A angle, and we would then have to use that in order to use our law of sines. And remember, if at all possible, we don't want to use a rounded answer to find another answer, because basically it makes our rounding error that much larger. Agreed? But what could we use again instead and not have to use any of our rounded? The law of cosines again, except this time we're going to use the one that has e squared by itself. And it's good practice for us to use our law of cosines anyway. So again, I'm just plugging in. Okay, so 19 squared gives us 361. And then 8 squared plus 14 squared. And then 2 times 8 times 14.
224.
Okay, so again, I'm solving for big B, so what do we want to do first? Subtract. Okay, so what do we get?
101.
And then we would divide negative 224. And then our last step would be take the cosine inverse of both sides. And what do we get for big B?
116.8.
80?
Just
But like if we round to 2 decimal spots, is it 80?
yeah. Oh yeah.
Good. Are we all okay with that? Were we all able to get that in our calculator, with whatever calculator that we're using? So that's going to be really important for most of our law of sines and law of cosines, is that we're able to plug everything into our calculator. Okay? Now from here, I'm going to go ahead and say we don't have to apply the law of cosines again. We're going to go ahead and just do, what is big C going to equal?
180 minus.
Agreed. Because we're only doing subtraction there and not taking like an inverse or squaring anything, it's alright to just plug in our rounded answers at that point. Okay? So what would we get for big C?
$41.12.
Do we agree? Alright, and so we have solved our triangle by finding our 3 missing angles. Are we all okay with that? Questions? Now, most of this is just like plugging and chugging, right? It's just plugging in the stuff to the formula and then squaring, multiplying, dividing, and subtracting. Really the only like trig part is the formula itself and then taking the cosine inverse at the end, right? But you wanna know where most people make their mistakes is going to be in all of the other stuff, the adding, subtracting, multiplying, and dividing. So as we're going through these problems, just make sure that you're doing them carefully. Now a lot of people's question is, like on my step 2, could I have just technically like plugged all of that into my calculator instead and taken the cosine inverse of all of that? Yes, just be careful, okay, because the more that you plug in at once in your calculator, the more likely you are to make a mistake somewhere, plugging it all in together. Does that make sense? Alright. So let's look at another triple side question. I want you to try this one on your own. Alright, so again, I just start with A because, I don't know, that's the order that I just like to go, that way I don't forget any of them. So our A is going to be 5 squared equals 8 squared plus 12 squared minus 2 times 8 times 12. Cosine of big A. 5 squared gives us 25. What is 8 squared plus 12 squared?
208.
208. And then 16 times 12.
192.
Okay, so then solving for A, we would do 25 minus 208 gives us negative 1, what?
83.
83 divided by negative 192. And then our last step is to take the cosine inverse of both sides. It ends up being a positive fraction because we have a negative divided by negative. And so what do we get that A is approximately?
17.61.
Do you agree? Alright. So then we could find our B next. It's going to work very similarly. So we're going to get 64 equals, we get 25 plus 144, which gives us what?
169.
And then we have 10 times 12, which is going to give us 120. And then solving for our cosine, we would do 64 minus 169, so we get 105 divided by negative 120. So we get that B equals cosine inverse of our fraction. And so we get that B is approximately what? 28?
25.5.
It's
28.9.
so you might check your fraction that you got the same thing as me and check it just when you plug it into the calculator that you put it down, right? Okay? And then how can we find big C?
Subtract both of those angles from 180.
And what do we get?
133, 143.
Degrees. So that's 1, 2, and 3 angles. Do you have any questions on that? Y'all fix any mistakes if we made one? Maybe the biggest thing. Again, a lot of the mistakes are just plugging stuff into the calculator, so be careful when you do that. So that was our first case with our law of cosines. We also have our second case. Remember, it was when we're given a side and then the angle and then the other side. Okay. Now notice, just like before, even if we wanted to use law of sines, notice that because I don't have little a, and because I don't have the angles across from either of my other sides, we don't have enough information to plug into our law of sines, which is why we have to use law of cosines. Make sense? And this case is actually, I feel like, a little bit easier because we don't have to solve for the cosine. It's just, we're going to do a side. And we're going to start, we have to start with our little a because that's the angle that they give us. So we would have a squared equals b squared plus c squared minus 2bc cosine of big A, plugging in the information that they give us. So 9 squared plus 12 squared gives us what? Okay. And then 2 times 9 times 12?
262.
And then what are we going to have to do with that in order to solve for A?
Work it out.
We could just calculate it like that.
You can't just calculate it like that.
Figure out cosine of 25.
Not quite. What do I have on my A right now?
You need the square root of
I have to square root of that. Now, technically, when we take the square root, what do we have to put in the front? Plus or minus. But if we're talking about the side of a triangle, what does it have to be? It has to be the positive one. So then we can plug all of that into our calculator. Now, like I said before, could you have just done the 9 squared plus 12 squared minus 2 times 9 times 12 cosine of 25 all underneath a radical in your calculator? Yes. But again, like I said, the more stuff you plug in at once, the greater chance you have of making an error somewhere. So that's why I kind of like breaking it down at least a little bit. But you don't have to. If you want to be lazy, plug it all in at the same time. Just make sure you do it really slowly and be careful. So what do we get that A is approximately? 5.41, and then what's our unit? Meters. Okay. Are we all able to get that? Now, from here, notice that we have two options, right? We have enough information now that we could use law of sines because we have small a and we have angle A. The problem being that we rounded to find little a, okay? But notice that if I wanted to find either of my other two angles using law of cosines now, I would also have to use little a still. So this is a problem where you can't get around using your rounded answer. So it doesn't matter which one we use from here. It's just going to be whichever one you feel more comfortable with. Yes, ma'am.
In this round of test, would you want us to use the cosine formula for the second part, or would you want us to, would it be okay for us to use sine? If it was asking us to use the law of cosine or whatever.
Yes. If I asked you to use law of cosines, I would only be asking you to use it to find the first one. From there, if I asked you to solve the triangle, you could use whichever one you wanted.
Oh, okay.
Does that make sense? Which is what I was getting to here, that it doesn't matter which one we use for the second one. It's just whichever one you feel more comfortable with. Some people would rather do the fractions because you only have to remember the ratios. Some people don't like fractions and having to solve those, and they would rather just the A's and B's and C's and addition and multiplication. It's just your preference, okay? I'm going to go ahead and just set up laws of sines since we did the last one doing the law of cosines. But like I said, you should get the same thing either way. So since we're solving for an angle, I'm going to go ahead and set up my law of sines with my angles on top. So remember, as long as we take the reciprocal of both sides, that is okay. And then I'm just gonna plug in. So we have sine of 25 degrees divided by 5.41 equals sine of big B divided by 9. So we would multiply both sides by 9. And then we need to take sine inverse of all of that. Again, when you plug that into your calculator, make sure you're really careful about your parentheses. That's what throws off a lot of people. Okay. And so what do we get that B is approximately?
It's 85.38.
Do we agree?
I got 24.7.
24?
No,
44.
40.67.
1, 6, 7, 8. So double check whoever said that first where your parentheses are.
Ms. Bennett, so when will we have to find the second time? Will we have to do that? Or will it be giving us a prompt to find it? Or will it be
You mean for our laws of science?
Oh, is that only for laws of science?
Yeah, so remember the only time that we have an ambiguous case is when we have side angle.
Okay, okay.
That's the only time that you could possibly have two solutions. Does that make sense? Okay. So then how would I find big C?
180 minus A minus B.
Agreed. And what do we get? So we found our missing two angles and our third side. Questions on that one? Okay. How are we feeling with laws of cosine? Pretty good? Okay, good job.
Geometry.
You did. Okay. So remember that in our last unit or last section, we looked at our law of sines area formula. We also have a law of cosine area formula. And basically what this is given all three side lengths, we can use this formula to find our area. Now, remember, you do have to have laws of sines and laws of cosines memorized for your test, but I will give you your two area formulas on your test. Okay? But we do have to know how to use them appropriately. So you have area equals the square root of s times s minus a times s minus b times s minus c, and then it tells us where s equals a plus b plus c, all divided by 2. And so basically they just set it up that way instead of having to put a plus b plus c divided by 2 4 different times in our formula. So most of the time you're going to find s first and then just plug that in. Okay, so let's look at the same one we got. So it says find the area of a triangle having sides of lengths A equals 43, B equals 53, and C equals 72 meters. So what did we say we need to find first? S. And so S is just going to be A plus B plus C, all divided by 2. So we have 43 plus 53 plus 72, all divided by 2. So what do we end up with?
84.
84. Then once we have that, we can just use our area formula, which remember is S times S minus A times S minus B times S minus C, all underneath a square root. So 84 minus 43 gives us. I just put it all in. Well, 84 minus 43, we should be able to do in our heads, is 41, right? Okay, 84 minus 53 is going to be 31. And then 84 minus 72. 12. Okay. Okay, and then if we do 84 times 41 times 31 times 12, what do we get? Big number.
Okay, hold up. 1,281,168.
And then if we take the square root of that, what do we get?
1,131.89.
Okay, and what's our unit going to be here?
Centimeters or meters squared.
Meters squared. So remember that we're finding area, so we still do need a squared unit. And so it's going to be our original unit, which was meters squared. Questions on that? Like I said, the biggest thing here is going to be making sure you plug into the formula correctly. After that, it's just plugging it into the calculator. Okay, so let's look at one last example. And it's going to be an application problem. So we looked at application problems of our law of sine. Now we're going to look at an application problem of our law of cosines. So this says the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet, as shown in the figure. The pitcher's mound is not halfway between home plate and second base. So it's just wanting you to know that you cannot assume that from the point P to like that top angle, you can't assume that's 43 feet. How far is the pitcher's mound from first base? So we're looking for H, little h. Okay? So what do we need to use?
Well, cosines.
Yes, because they tell us so, but why could we not use law of sines?
Because we can't find another angle across the side that we're given.
Correct. So I'm looking for little h, which is directly across from my 45, but I don't have either of the other angles, so we don't have enough information to use a law of sines. Now, just because they use different variables doesn't mean we set our equations up differently. You're just going to set them up with those variables instead, which is why I said really we only need to memorize that first equation because everything else is just going to follow very similarly. So here we would have f squared plus p squared minus 2fp cosine of big H. You don't have to set that up. I'm just trying to show you where I'm getting all of my information from. So 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45. So what is 43 squared plus 60 squared?
5,449.
Okay, and then 2 times 43 times 60.
1,160.
And we should know what is the cosine of 45. Square root of 2 over 2. And then what do we need to do to solve for h? Take the square root of all of that. And what do we get?
I got 42.43.
What is our unit? Now, does 42.43 feet make sense in terms of our problem? Yeah, I mean, it's kind of in between, or it's a little bit less than 43, but it's still within the realm of reason. That's a good thing to check about whatever answer you get. One, would it make sense for us to get a negative answer? No. Then we know we did something real wrong somewhere. Or, and then two, would it make sense for us to get like 500 and something?
Absolutely not.
No, because again, we're talking about a baseball field. All of your dimensions are going to be relatively close to each other. Does that kind of make sense? So when we're working application problems, it's going to be a big thing there at the end. Make sure your answer makes sense, okay? Other than that, a lot of people get scared by the application problems because they're words and I have to read and all of that stuff, but really, it's not any different. Basically, you're just looking at the picture. The picture just has context now, but I'm still plugging it in and evaluating it the same way. Okay? Usually the hardest part is if they don't give you a picture, drawing your picture correctly. And usually that's where people tend to make mistakes and not actually with the like plugging in and stuff. So, any questions about any of our law cosine stuff?